Welcome to Networks Learning. My name is Riyaz Gul. In today's video, we are going to see how you can do destination NAT with extended routing. Extended routing means your private IP pool or the public IP pool is not directly binded on the firewall interfaces. So in this case, we are having one public pool, which is 10.50.0, and which is routed from the ISP towards our firewall, and we want to use this subnet to have a destination NAT configured for one of our LAN services which are not directly attached to the firewall. So in this case, ISP routes your public pool towards your firewall, and you need to route your public pool towards the destination or towards the pool that for which you want to have a destination NAT to be configured. So in this case, we are having edge router, firewall, and LAN switch. In previous video, I have shown you that how you can do dynamic destination NAT. In that case, our LAN pool and our public pool both were residing on our firewall, but in this case we are having one public pool and the LAN pool which is not directly attached to the not directly attached to the firewall interfaces. So from firewall we have routed this subnet 192.168.2.0 towards this LAN switch, and this LAN switch is having connectivity with the Tor switch. So we want the scenario is we are having one public pool which is not directly attached to the firewall, but routing is there for this subnet from ISP, and from firewall we have routed this subnet towards LAN switch. Why we have routed this subnet towards LAN switch? Because we want to have a NAT configuration, destination NAT configuration for one of the subnet that is residing behind this LAN switch. So in this case, we need to provide firewall with the visibility of both the subnets for which we are performing the destination NAT. First, the destination IP 10.50.0/29 subnet where it's residing, we need to tell the firewall, we need to tell this that this is routed towards ether 1/2 towards the LAN switch. And similarly, we need to do the routing for 192.168.2.0, the subnet behind the LAN switch, towards the LAN switch. From firewall we need to create two static routes towards the LAN switch. So first, before moving on to the configuration, I'll show you some of the subnets and objects that I have already created for you. So over here we have a destination NAT LAN Tor switch. This is the private IP address on the switch 192.168.2.2, and this is the WAN IP, DNAT WAN 1 IP from the subnet 10.50.0. So we'll use the 10.50.1 on this firewall to destination NAT to 192.168.2.2, which is the Tor switch. We'll enable the configuration on IP level so that we don't have any issue with respect to the configuration. You can also do the dynamic NAT, which I already configured in my previous video with multiple ports. So I'll show you the IP addresses on Tor switch. This is the IP address 192.168.2.2. So we want 10.50.1 a public IP address to have a destination NAT against 192.168.2.2, but both of the subnets are not directly attached on the firewall. So first I show you the objects, then the second part is routing. You need to have a routing for both of your subnets to tell the firewall where you need to route the packets based on these destination. So we have LAN 1 subnet. This is the LAN subnet, and this is LAN 1 subnet behind the LAN switch. This 192.168.2.0, and it's going to 192.168.1.150. 1.150 is the IP address on this LAN switch for this segment. The second pool is WAN 1 public pool. We are routing this pool towards the LAN switch to tell the firewall, because our destination NAT private IP address is residing behind this LAN switch. So when you configure NAT, there is a one decision making capability by the firewall based on the routing, that where to route the packet based on the destination configuration. So that's why we need to route 192.168.10.150.0, which is a public pool, towards ether 1/2. We just need to tell it firewall that it's residing on ether 1/2. That's it. We don't have to provide any next hop IP address. So these two routes you need to configure, and now we'll move on to the configuration part. In the policies, from my previous videos I have these configurations, so we'll not go into the modification of any of these. So these will still be in working condition. First you need to go into the NAT. We'll have a NAT policy with the name of Destination NAT for lane 1 on any of the ports. Okay. Source zone would be, the packet is coming from WAN. Yeah, here why I created a static route for the subnet for which we want to perform destination NAT, because you need to select where is the zone. The source zone is WAN. Once the packet arrives at the firewall engine, firewall have to decide where to route the packet for destination address, which would be the public IP 10.50.10.150.1. For this subnet, where is the routing happening? So in this case we'll have to select the destination zone as lane, because our public IP is routed towards the lane segment, which is Ethernet 1/2. Sorry, yeah, correct. Ether 1/2 is binded towards the lane zone. Packet coming on firewall first have to, the routing takes place first. So first routing, then it will go for NAT, then it will go for security policy. Packet is coming from WAN, and destination zone over here is going to be the lane, because firewall will have a route lookup based on the destination address, which is 10.50.10.1, and it will find it to on the interface 10.1/2, because we already routed, because our lane segment is residing on lane switch. That's why we routed this. In other security NAT policies, you can see that destination zone is also WAN, because we were using the public IP of the firewall, which is on WAN address. But in this scenario we are using a destination NAT for a public IP which is not directly binded on the firewall. So in this case we need to select the zone where the public IP pool is being routed. So it would be the LAN, destination LAN interface 1/2, service any. We are going on any service. Destination address over here will be destination at WAN 1 IP, WAN 1 from the pool of 10.150.0. Translated address, we are going in destination NAT, static IP. You need to configure the destination lane 1 IP address. Lane 1 subnet, you should have DNAT WAN, DNAT WAN, DNAT LAN Tor switch. This is the IP address for the switch. Okay, we'll move it to the top. Then you need to configure security policy. Allow DNAT LAN 1 Tor switch. Source coming from WAN. Source address could be any. Destination zone. Here in the security policy, you need to select post NAT zone. It would be LAN, and destination address in this case would be pre-NAT WAN IP, which is DNAT WAN 1 IP. Application any, service any, action allowed. Move it to the top. So I'll commit the changes. Once the commit is successful, I'll return. So I'll pause the video till that time. So the changes are successfully applied and completed. So one more thing I need to tell you is that I'm having one of the edge router over here, and from my physical machine I have a routing entry, static routing entry for 10.150.0/29. in order to initiate a request from outside of the firewall to verify the destination NAT. So I'll show you the routing entry 10.150.0/29 routed to 136.192.168.137.136 is the IP address on my edge router. 137.136. Yeah. You can see over here. Is dynamic IP, and I am routing 10.150.0 towards the firewall ether 2 over here, ether 1, sorry. 10.150.0 ether 2. Okay, it's routed towards the firewall. So now we need to verify the configuration. So I'll initiate a connection from my physical machine on, because it's IP level communication, so we can initiate any traffic from outside 10.150.1. Yeah, you can see over here we are able to ping the LAN machine which is residing not directly on firewall but one of the segment of the network behind the firewall. So in this case you can perform NAT on any kind of your LAN segment if you have a firewall or any NAT device on which you want to perform the NAT. So I'll verify this configuration on Palo Alto Firewall. So it's better to go with the traffic. So you can see over here, this is the entry against the traffic which we initiated once. So it's matching with the allowed DNAT lane 1 Tor switch policy. The source is 192.168.137.1. Each interface is 1/1 and destination is 100.50.1, which is the public IP address we used. And interface is ether 1/2 and NAT IP is 192.168.2.2, which is our Tor switch IP address. So this is how you can perform destination NAT using different scenarios or based on your requirement inside the network. Thank you so much for watching my video. Make sure you like and subscribe my channel for more videos. Thank you so much.